Hi. Well, big day. We finished our discussion of octet violators, and we have one more to do. This is based off octahedral, and it's interesting because the example actually uses a noble gas. And I know a lot of you guys, because you're really bright and have studied the noble gases, will say, well, noble gases are, inert. They don't really make compounds. But the larger noble gases, including xenon, actually will make compounds when you put them with something that is highly electronegative, like fluorine. Okay? So in this case, we will move away from that idea that the noble gases never combine, and we'll actually make this compound with it. Now, it does violate the octet rule in a pretty interesting way. So, first thing, we have one xenon, and that has 8 valence electrons because it is a noble gas. And then you've got 4 fluorines, and 4 times 7 is 28. 28 and 8 is 36. We have 36 valence electrons. I don't think that's quite the record, but that's a lot of valence electrons. So, now obviously, if you've watched the video series, you know that fluorine cannot violate the octet rule. And even if you have something like a chlorine or a bromine or something like that, if you have another element, they're more likely to be the central atom because halogens just really most often want to make one bond, but fluorine can only make one bond. And so we're going to put the xenon in the central here, and then I'm just going to attach my fluorines like this. F, 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 like all my grades in physics class. Okay, and then once we have that skeleton done, that takes 2, 4, 6, 8. 16 minus 8, I have 28 valence electrons. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And again, like that. And then that's 6 times 4 is 24. And so I've got 4 left. So I've made everything. That's a little messy, sorry. So I've done all my fluorines, and they're all good. But I've still got 4 electrons left. Now, somebody that's not super bright about chemistry would say, well, that xenon's just got 2, 4, 6, 8. It's happy. All the fluorines are happy. Let's move on with our lives. You can't leave these 4 electrons out there hanging out. If it's in the structure, if it's in the valence, it has to be in the compound. So we'll attach them, boom, 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 on the xenon. And you see there's 1, 2, 3, 4, 5, 6. To violate the octet rule, there's 12 around the xenon. That's okay. It's not that big a deal. So when you look at that in 3D, you take this one off and this one off, okay? And it actually sits off like this, okay? And that way, everything, you want these unshared pairs to be as far apart as possible. That's why we don't do this, because you see here how they're closer. You want one unshared pair up and one unshared pair down, and that puts them 180 degrees apart. So we need to come up with a way to draw this. Now, you could do it kind of like this, but most often what we see is 2 going in the back, 2 coming out, and then the unshared pairs on the top and the bottom. So I'll draw that real quick. Okay. And so you see how there's our square here that we needed to make. And then you have an up and a down. So there's your square around kind of the belt. And then there's your up, there's your down. And we call that square planar. Okay? And the reason why it's because it forms a square and it's in the plane. Now, let's go ahead and do the formal charge here just so we can remember what formal charge is. But I'm going to do it different this time. Haha, I'm going to do the fluorine first. There's only one way to do formal charge. So fluorine has 7. It has 6 unshared plus 1/2 of 2 is 1. 6 plus 1 is 7. 7 minus 7 is 0. And then xenon, it has 8 minus, it has 4 unshared plus 1/2 of 8 is 4. 4 plus 4 is 8. 8 minus 8 is 0. And so, there's formal charge fluorine, formal charge xenon. They're both happy with it. They're fine with it. And so, thus ends our discussion. You should be pretty much an expert on Lewis structures and geometric drawings now. Any questions? Send them my way. Catch you later.